In this video, we're going to be talking about the Rect transform. Now, the Rect transform is a component that's largely responsible for the positioning and the sizing of each element in our UI. Every game object that exists underneath a canvas is going to have a Rect transform instead of its normal transform. So we're all familiar with the typical game object transform. If I click on the main camera and hop over into 3D space, we see that we have the transform up here on the top right, and we can manipulate it using some of the normal scene view gizmos, such as the movement tool or the rotation tool. Now the Rect transform is a very similar concept, but it's suited towards a two-dimensional interface. The Rect transform essentially indicates to the UI system where an object should be positioned relative to its parent game object. Now, we're going to take a look at the Rect transform and its major components, the anchors and your pivot, in this video. But again, I don't necessarily expect everybody to gain an immediate intuition for how the Rect transform works. And the reason is it can get a little bit complicated. The Rect transform has a variety of different states that it can be in, depending on how things are positioned. So I encourage people to watch this video and at least get some of the concepts understood, and then go out and play with it yourself to get a better feel for how you can use it to build your interfaces. So yeah, stuff and things. Let's go ahead and create a canvas and talk about the Rect transform. So over here in my hierarchy, in order to create a UI system of any kind, we're going to have to start with the canvas. So I'm going to right click on the blank space, go under UI, and create a canvas. And so now we see our ridiculously large canvas outline in our scene view that we discussed previously in the last video, and I'm going to keep it on screen space overlay. Because we're not going to be working with any perspective in this video. So the first thing that you may notice if you're paying attention to the inspector here is that the canvas does indeed have a Rect transform itself. But as we saw in the last video, the Rect transform on the canvas is not actually going to be modifiable by us unless it's in the world space render mode. So by default, the Rect transform of the canvas will take on the characteristics of the screen. So as you see right here, as I resize my screen, my game view, the canvas changes as well. And we are not able to modify any of those parameters. There are ways to modify the scale of a screen space overlay and screen space camera canvas, but you do that through a different component that we're not going to be looking at in this video. Okay, so I'm going to hop over into 2D mode. Again, the button up here on my scene view just shoots my scene view over into an orthographic view, so it makes things like working with the UI a little easier. And then I'm going to right-click the canvas, select UI, and I'm going to create a panel. And in fact, you know what? To demonstrate one of the biggest, or one of maybe the more difficult to understand concepts of a Rect transform, I'm going to create a panel, but I'm also going to create a button. I'm going to right-click panel, and I'm going to select UI, and I'm going to select button. And the reason I'm doing this is I want to show an example of two different configurations of Rect transforms that give you two different bits of behavior. So in this particular case, we have a panel that was constructed through the create menu that has its default values, and a button that has its default values. You'll notice immediately that they look very different. The panel fills the entire canvas, whereas the button is centered on the panel that it's a child of. And the interesting thing about this behavior is that it's not actually behavior that is limited to only the button or only the panel. It just so happens that the button and the panel, when you create them, they're set up with different kinds of Rect transforms by default. So let's go ahead and first look at the behavior of the panel and the button. Now, when I say behavior, what I'm in this video in particular, what I'm referring to is what happens to the position and the size of an element as its parent element changes. Because everything is going to be relative to its parent in the new UI system. And so a big portion of our development with the UI system is going to be asking ourselves, what happens to the characteristics of this UI element as the parent changes? So how do we facilitate the creation of flexible user interfaces that don't rely on absolute pixel coordinates? So what we can see right here is our game view. And you'll notice that as I resize the game view, the size of the canvas changes. In fact, the size of the canvas is really the only thing that changes as I resize the game view. But you might be looking at the screen and say, well, clearly the size of the panel is changing too, but that's not really important. It's not important because the size of the panel is really just following the size of the canvas. So again, the only thing that's changing here is the size of the canvas as I resize this. Another trick I can show you guys for how to preview what happens to our UIs as we modify the size of the parents is if we select a UI element such as the panel. Well, that's not going to be a good example. Unfortunately, it's not going because it's in fill mode, so we'll show that later. But let's say I select the button. I have the button selected. Watch what happens as I move the panel. So I can resize the panel in what's called a preview mode. So you see the little word preview right there. And what that means is I can test to see what happens as its parent changes its size without actually modifying those values. So again, I have the button selected and I'm able to resize its parent. In this example, unfortunately, since the panel is filling the canvas, the only way I can demonstrate the panel moving is by moving the game view, and thus changing the resolution, which changes the size of the canvas, which changes the size of the panel. So what I wanted to show in this example was two different game objects, two different types of objects, a button and a panel, and them both behaving differently. You'll notice that the button is always centered, whereas the panel is always filled. Now, like I said previously, this behavior is not inherent to either the panel or the button. In fact, this behavior exists on all objects that have a Rect transform. The differences between the panel filling the canvas and the button centered on the panel is simply described as a different set of values on each respective game object's Rect transform. So let's take a look at what that is. The first thing I want to point out, though, is we're going to be almost exclusively working with the Rect transform tool. The Rect transform tool allows us to manipulate and visualize the way a Rect transform is set up within our scene view. So the Rect transform tool is going to be right next to our scaling tool, as you can see right here as I switch between the different tools. So if we click on the panel, we see the Rect transform gizmos appearing. And there's a couple points of interest here. First of all, we have our center, which is represented as this circle that doesn't have a center, a hollowed out circle, which represents the pivot of the game object. In this case, the pivot happens to be in the center of the game object, but we can see, we'll be seeing very shortly how we can change that. Another thing is you'll notice we have resize handles up at the top right, and the bottom right and bottom left and top left. So these resize handles do what you would expect them to. They allow us to resize the element. We can also drag on the side of the game object as well to resize it. Now, what does resizing mean? Well, we'll talk about that very shortly because, as you'll see, describing UI elements in terms of width and height isn't actually the most appropriate way to think about it in most cases. Now, the final bit that I wanted to look at with the Rect transform tool is the distinguishing factor between the panel and the button, the reason why the panel stretches and the button stays in the center, and that is our anchor. So hopefully you guys can see the anchor points. They're on each four corners. We have a top right, top left, a bottom left, and a bottom right, and they're these little guys right here. And we can click and drag them and see them visually. Now, it's interesting to note, as I click and drag these, you'll notice on the left-hand side of the screen and on the bottom side of the screen, we have a percentage, which indicates to us that the way that we position our anchors has more to do with a proportion than an actual pixel value. And again, that is one of the most fundamental things a person has to understand about the way this UI system works. We can also see that represented on the right-hand side in our inspector. The Rect transform, as you see, is made up of a variety of components. We'll talk about this big button later. We'll talk about these four values later as well. But let's focus right now on the anchors. You'll notice as I move these, their values change. And you'll notice that the anchors are made up of two-dimensional vectors, a minimum and a maximum. You'll also notice that they move between values of 0 and 1. Furthermore, if you're in your Rect tool and you try to increase the size of an anchor beyond that of the size of its parent, it will not let you. The anchors are always going to be constrained to the size of the parent element. There's no way to get around that. So again, just to recap, an anchor is a percentage value that goes between 0 and 1 that can only be as large as its parent and can be as small as 0, as you can see by me dragging it all the way to the bottom left. But what exactly do the anchors do? Well, the anchors basically describe the relationship between the size of the child and the size of the parent. As you can see, right now our anchors are in what's called stretch mode. In fact, you can see that represented here on this box that I wasn't going to talk about. It's stretching both horizontally and vertically. But you'll notice that as I change these values, it changes. So there are basically going to be a couple of different very common situations that you have with anchors, and they'll all have a different sort of behavior to them. For example, in this we have a uniform stretch. Now the uniform stretch will always happen if the anchor points are separated. So you see that the anchor points here are completely separated. We have 4 individual points. Now let's look what happens when we move our anchor points to be combined like this. So what I basically did is I took this top right anchor point and I accidentally rotated the panel for some reason. There we go. There we go. I took this right-hand anchor point and I dragged it all the way to the left, which combines it with its other anchor point. Now, you'll look at the screen and say, well, not a whole lot changed. I mean, why would you do that? Well, watch what happens when I come over to my game window and I change the size of my canvas. You'll notice that as I change the size of my canvas, the panel does not change horizontally, but it does change vertically. That's because we're in a stretch mode on one axis, but on the other. Basically, we've told this panel to dock all the way to the left of the screen and not get any bigger or any smaller on one axis. We can also do the same thing on another axis. So watch what happens when I come over here and I'm going to take this and I'm going to move it. Whoops. Here we go. I'm going to now anchor it to the top like this. So if I anchor to the top by moving the 2 points to the top of the screen, you'll notice that it behaves like this now. It's sticky to the top of the screen. You'll also notice something interesting as well here, and this is another important feature of how anchors work. You'll notice that there's a padding between where the panel is docked to its parent and where the panel's size actually is. So there's this padding. Now note that since the anchors are positioned at 100% on this axis, this padding will be maintained as we stretch further. So I could take this padding and I could reduce it by clicking on the panel and clicking and dragging one of its sides. And let's move this padding to be 24 pixels. Now you'll notice that 24 pixels is maintained because it's a uniform, it's a stretch that's going to always happen proportionally. Okay, so that is how we can sort of stretch on both axes, and that's how we can stretch on one axis. There's another thing that we can do, and that is simply moving the anchor point, or the entire anchor, around the screen. So what does this do? Well, when we combine all 4 points of the anchor into one point, so that we're no longer performing any sort of stretching, we're simply saying where we want this element to appear on the parent and not move. So for example, if I were to center this, so I've centered the anchor point. You can notice over here on the Rect transform that the min and max on both X and Y are 0.5 or 50%. So now if I stretch its parent, you'll notice it actually is starting to behave like the button. To make this example a little clearer, I'm going to go ahead and not only center the anchor point, but also center the game object itself. So now we can see the behavior of the panel not resizing and not stretching at all. It's simply in the center of its parent at all times. What if we wanted the panel to be on the left-hand side of the parent at all times but not stretch? Well, we can do that too. We can simply move the anchor over to the left of the screen, and then for good measure we could also dock the original position of the panel on the left-hand screen as well. By moving the anchor to the left-hand screen, you'll notice that the distance between the left-hand side of the screen and the panel is maintained as the screen is resized. However, no stretching happens. So basically what we have going on here is the ability to dock a panel on a side of the parent. So we could also do that at the top right. Again, if I put it at the top right, the distance between the top of the canvas and the top of the panel and the right of the canvas and the right of the panel will be maintained. As you can see, that distance continues to be maintained because of the position I have the anchors in. I know you guys might at this point be incredibly bored, like saying, oh, he's just sitting there playing around with his anchor, I get it already. The anchors are incredibly important, and I'm just trying to really drive home the point that it's really, the anchors describe the relationship of the child's position relative to the parent's size. And that's it, really. Let's talk about one more thing that I really don't expect people to really take to heart yet or find even a use of at this stage of the game, and that is we've at this point seen the anchor points being kind of docked at some location, whether it be the top, right, left, or bottom. But you'll notice that the anchors allow us to actually split in a percentage, meaning I could move the anchor point over here and split it like that. So what does this anchor mean? Well, this anchor setup means that the panel is going to resize horizontally 78% of the size of the parent and vertically 47% of the size of the parent. Now this is a very difficult thing to visualize. So let's go ahead and look at the preview as I resize the canvas. So you'll notice immediately that as I change the size of the canvas, so pay attention to the anchor points. Ignore the panel. Do not look at the panel. Are you looking at the panel? Stop. Look at the anchor points. Watch them as they get bigger and smaller. So what's happening here? Well, you'll notice that the distance between one of the corners of the panel and its corresponding anchor point never changes. But the distance between the anchor point relative to its parent's edge does change. And again, that's because we describe anchor points as percentages. So what's a possible use of this fact? Well, we could go ahead and move our panel right there, and we could say, I want this panel to be 50% of its parent at all times. So what I did there is I added in I split apart the 4 anchors, and then I docked the panel into the anchors. I could also throw in some additional padding as well to make this a little bit more interesting. But the point is what we're looking here is twofold. First of all, we want the padding to be maintained on the left, right, or left, top, and bottom. You see this little extra space right here next to the canvas, or between the canvas and the panel. We want that to be maintained. That is a fixed value. But we want the size of the panel to increase and always take up 50% of its parent. So that's why we split our anchor into 2 points, and we moved it to be roughly 50%. I overshot the first time I did it, parent. So let's move that to 50%, and then let's introduce some right padding. Now as we stretch it, you'll notice that the panel will always take up almost exactly 50% of the screen. The only reason it's not exact is because of the additional padding I added. So hopefully for somebody who may have played around with another GUI system, you'll start to realize the power of this. Because I can deliberately say, make a statement such as, I want a panel to take up 50% of the screen, and I want it to have a fixed pixel padding around the edge of the screen. And we've accomplished that simply by positioning our anchors. You can see an example of this in the game view right here. But what if we only wanted it to resize in one direction? As you see, it's resizing in two directions. Well, again, that's easy. The basic rule of thumb here is your anchor points are going to be in one of three modes. They're going to be in single point mode, which I don't know if that's, I'm just making up terms right now to help explain things. I don't know if actually it's referred to that as that, but that's what I'm referring to as. So you have a single point mode where there is no resizing. You have a 2-point mode where there is a resizing on one axis, in this case horizontal, in this case vertical. And then you have 4-point mode where you have resizing on all four axes. So again, if we only wanted this panel to stretch horizontally and not vertically, we could have simply placed our anchors set like that using a 2-point anchor, where our panel now does not resize vertically. Now you might be wondering, well, what if I wanted the panel to stay in the center of the screen as I resize vertically? Well, that's easy to do. We remain in 2-point mode, but then we simply drag the 2 points. Whoops. We simply drag the 2 points to be exactly in the center of the game object, or of the parent. And now you see that the object will remain in the center. Okay, so what's the difference between when I create a panel and when I create a button? The answer to that question is the way the anchors are set up. Because I could have just as easily taken this button, grabbed his anchors, docked them to his parent, resized the button a little bit, and the button will now stretch to fill the parent. Alrighty, so those are anchors. Very, very, very important. I did spend a lot of time talking about them, I know. I hope I didn't bore anybody, but they're very, very, very important for understanding how this UI system works. So now let's talk about pivots. So what I'm going to do is I'm going to go ahead and delete this panel on the canvas, and I'm going to create a new one. So I'm going to come up here to Canvas, right-click, UI, Panel, and then I'm going to make it a little bit smaller, I guess. I'll keep it at stretch full, but let's just make it a little smaller so we can talk a little bit about pivots. So what is a pivot? Well, a pivot is really just a point inside of the game object that determines how it should be scaled as well as how it should be rotated, and even positioned. Basically, you can think of a pivot as the origin of a game object. So you know how our world has an origin? Well, we can also give our local Rect transforms their own origin, and the origin of a Rect transform, like I said, determines a variety of things: position, scaling, rotation. It also determines how we calculate positions. We'll talk about how we calculate positions a little bit later when we discuss these 4 numbers, so just ignore these 4 numbers for now because they're going to get really crazy as I move this pivot around. So don't worry about those numbers just yet. So anyway, the pivot, as you see, is by default going to be in the center of a game object, and you can see that right here. So I can click and drag this pivot. A couple things to note about the pivot. First of all, we can see the numeric representation of the pivot right here in the Rect Transform Inspector. And you'll notice that it is a value between 0 and 1. We could also make it larger than 1 or smaller than 0 as well, because unlike anchors, we can actually move them wherever we want. Okay, so for a quick example of how pivots affect position, rotation, and scale, I'm going to make use of some animations. So I'm going to right-click the panel, click on UI, and create a button. So you'll notice something interesting about this button immediately after our discussion about anchors, in that it's anchored in the center of its parent. However, in this demonstration, the anchor position is not going to make a difference at all. Instead, we're focused solely on the pivot. So what I'm going to do is I'm going to animate this button getting bigger and smaller through a scale. Effectively, I'm simply going to scale its X. And then we'll see how the change in pivot changes how it scales. So to create an animation on a button, we go over to our animation window that you could find through Window, Animation. And I'm simply going to say, click on this little empty drop-down thing and say Create Clip. And I'm going to call this clip Button Rotate. Now, then what I'm going to do is I'm going to scrub out to... Oh, come on. And we got a frozen Unity. There we go. What I'm going to do is I'm going to scrub out here to about 1 second, and I'm going to take his scale and I'm going to increase it, maybe to about 1.81. And of course, we're not getting any automatic keyframes, so let's go ahead and leave the scale right there at 1. Let's scrub over to 1 second, then I'm going to select Add Curve, Transform, Scale. Then on my dope sheet, I'm going to move over to one where I have these keyframes, and I'm going to set the X scale to 1.8. You know what's going on here? I added an animator controller to my camera. I've been scaling my camera. Way to go. Let's go ahead and delete that. Let's go back to our button. I'm going to delete these two. I'm going to go a little bit another way to bank this animation. Sorry about that, guys. I'm going to go to Project, hit Create. Let's jump down to Animator Controller, and let's call Button Controller. And then on Button, I'm going to scroll down to Add Component, and I'm going to add an animator. Then I'm going to click and drag Button Controller onto the controller. Now what I'm going to do is I'm going to open up the dope sheet, and it's going to ask me to create a new animation, and I'm going to call this Button Scale. Then I'm going to move over to 1 second. I'm going to change its scale to 1.8. And now we have an animation. The final thing I'm going to do is I'm going to move over to 130, and I'm going to change its scale back to 1. And again, I'm in record mode, so you can see that the keyframes are automatically added in. Now I'm going to exit record mode, and I'm going to duplicate this button a couple of times. And on each button, I'm going to set a different pivot on it, so we can see the effect that different things have with pivots. So I'm going to duplicate it, move it down, duplicate it again, move it down, duplicate it again, move it down. So on the first button, I'm going to leave its pivot in the center. On the second button, I'm going to move it over to the left. On the third, I'm going to move it to the right. And on the fourth, I'm going to move it way over there. Now let's watch what happens when we hit play. So you'll see that these buttons all have the exact same animation applied to them. They're all doing the same thing. They're all increasing their X animation value, as you can see in the inspector right here. But you'll notice that they look very different. One is growing from the center, one's growing from the right, and one's growing from the left, and one's doing this crazy little thing right there because the pivot's like way over there. See, as you see, as I move the pivot around, strange things start to happen. So again, the pivot just determines, in regards to scaling, where we grow from. So if you want to be able to scale something and have it grow from left to right, we place the pivot on the left. If we want it to grow right from left, we place it on the right. And so on and so on. The pivot also has, the way that it does this is very interesting, but requires that we talk about these numbers that I don't want to talk about yet. So we'll get to that momentarily. So now let's do the same thing with rotation. So I'm going to go a little bit faster this time, because I think most everyone's getting the picture here. I'm going to create a button rotation controller. I'm going to right-click panel, and I'm going to create a couple buttons, or I'm going to create one button to start with. I'm going to add an animator to it, not an animation. I'm going to click and drag button rotation controller onto it. Then I'm going to create a new clip, and I'm going to call it button rotation. Then what I'm going to do is I'm going to set up a keyframe at 1 second and set its Z rotation to 360. Now I'm going to exit record mode, and I'm going to duplicate this button a couple of times, and I'm going to change its pivot on each button. So this button I'll have on the left, this button I'll have on the right, and this button I'll have somewhere else. Now when we hit play, we'll notice that the buttons are rotating around in different positions. Again, the exact same buttons, the exact same anchors, the exact same animations. The difference is the pivot. So the pivot just determines where the object rotates around. Again, where is the object's center? Alrighty, so that's pretty much pivots. They're pretty straightforward. If you're familiar with how sprites work, it works in the exact same way. I just really want to drive home the point of how pivots work and show you guys some visual examples of that. So hopefully at this point, you guys are starting to get a feel for how anchors and pivots work. Anchors and pivots are really the two most fundamental aspects to the entire positioning and sizing system of this GUI. So now let's talk about those four numbers. Because now that we have an idea of what the pivot is and what the anchors are, we'll see how those numbers change. The numbers I'm referring to are the position X, position Y, width, and height. No, wait, I'm actually referring to the left, top, right, and bottom. Or I could be referring to the position X, the top, the width, the bottom, or the left, position Y, right, or height. So as you can see here, these numbers actually change meanings. The labels on the actual numbers change depending on how I have the anchors set up. Basically, these four numbers are going to be responsible for the overall size of the object as well as where exactly it's positioned. So these four numbers have three different meanings depending on how we have things set up with our anchors, and they will be used to calculate the final size and position of a game object. So let's go ahead and delete this panel, or I kind of like this panel, so I'm just going to deactivate it and move it off to the side. I'm going to go to my canvas, I'm going to right click, go to UI, and create a panel. So in this panel, we'll see immediately that we have a left, top, right, and bottom. And you'll notice that as we drag, the values change. So you'll notice that when we're in this stretch mode, the size and position of the element is going to be determined by padding. When I say padding, if you're not familiar with technologies like CSS, it refers to the amount of distance between the parent and the child. So, in this case, these four numbers are referred to as padding, and we can modify them by clicking and dragging, or by typing in values such as 100, 100, 100, and 100. Now you'll notice we have 100 units of padding, or 100 pixels of padding, between the edge of its parent. It's not actually really between the edge of its parent. It's going to be between the edge of the anchor. So now we're starting to really put some things together. Because these numbers are actually going to be the distance between the edge of the rectangle and the corresponding edge that is created by these two anchor handles. We can see that visualized by me moving it in the scene view. We can see that number changing. As it gets closer to the anchor point, it approaches 0. As it gets further away, it gets larger. If I overshoot, it becomes negative. If I move the anchors in here a little bit, we see that these values are still attached to the anchor because these values are fixed. The anchor will move because the anchor is relative to the size of the parent, but the distance between the side of the rectangle, child rectangle, and the side of its anchor points is not going to change. So once this value is at 199.5, this is always going to be exactly 199.5 units, or sorry, pixels away from its anchor points. Okay, so I want to point out another thing that happens quite frequently with the UI system, and something that could be very confusing and daunting for people who may be new to it. And that is, these four numbers, not only do they change in meaning all the time, but they also actually change in value all the time. They have to in order to maintain a consistent editing experience as you're mucking about your UI and your scene view. So we can see here that as we move our anchors around, if you pay attention, so don't look at the anchors this time. So stop looking at the anchor, look at these four values. Watch what happens as I move the anchor around. The values are changed to compensate for the fact that I'm moving the anchor. Because if I move the anchor around without modifying these values, the actual size and position of the child would change. So you'll see that it's going to compensate for even typing in values. So again, just point that out. Okay, so we've talked about the first mode of how we can have these four numbers arranged. The left, right, top, and bottom, and how they're simply the padding between one of the edges of the element and the edge that's created by the anchors. If we move these anchors to a 2-point mode, for example by docking it on the left-hand side of the screen, you'll notice that we now have a position X, a top, a width, and a bottom. So you'll notice that our top and bottom still is determined by padding. So this is still a padding value. But our width is no longer determined by padding. Our width is now an actual width, an actual pixel value that determines the width of the element. And we can see this visualized on the bottom of this child panel right here, because as I stretch it and make it larger or make it smaller, that number changes. So we're now working with a fixed width. See, the padding is relative. Padding is going to always be relative because the anchor points will move and increase or decrease the size of the child. But widths and height are constant. Okay, so that's the width, and that's the top, and that's the bottom. But what about this position X? So you'll notice that as I move this around, the position X is a number, and we can see this through that dotted line that appears. It's a number that determines the distance between the pivot of the object and the corresponding side, the left-hand side of where the anchors are positioned. See, if I move the anchors in like this, we'll notice that the position X now plugs into where these anchors are positioned right there. And you'll notice as we approach 0, we get a really, really small floating point error. That's supposed to be 0. And as we get bigger, we go positive, and as we get smaller, we go negative. So this position X is a fixed value that won't ever change by default when we stretch our parents. And it determines, again, the distance between the pivot and the anchor. So what happens if we have the anchors positioned in a different 2-point setup? Meaning, instead of being stretching vertically, we want to stretch horizontally. So what happens here? Well, pretty much the exact same process, except using different values. You'll notice that we now have a left padding and a right padding. You'll also notice that we have a position Y. Position Y is that vertical number, that's that 305 right now, that's pointing at our anchor points. And the left right padding and the right padding corresponds to those two values on the left and right of the screen, or of the panel. You'll notice that we also have a height. That it's visualized very similarly to how the width is visualized. So again, we're in a different mode, but it's pretty much the exact same thing as what we saw before, just flipped on a different axis. So we've seen what happens when we have 4-point mode. we get 4 levels of padding. 2-point mode, we get 2 levels of padding. What happens when we go to 1-point mode? Well, in this case, we have no padding. Basically, we are now at a fixed height that will not stretch, as you can see represented right here. The height does not stretch. It is a fixed value that we type into the inspector. We have a fixed width, same sort of deal. We have a fixed Y position and a fixed X position, and you'll notice that they're still relative to that anchor. So you'll see that when we're in 1-point mode with our anchor, the X and the Y values are simply the distance between the pivot and the anchor position. All right, so those are the 4 modes that we can, or the 3 modes that we can be in with the Rect Transform tool. So let's talk about how this affects the pivot, because you'll notice that I did that demo with rotation and scaling, but I didn't talk about how the pivot affected position. But in reality, the pivot is what actually defines position. As you can see, when I move this around in 1-point mode, we're changing the values based on the distance between the pivot and the anchor points. What happens if I simply change the pivot position? Well, if you look on the inspector right now, you'll notice that the position X and the position Y are changing to compensate for my change in pivot location. Again, this is some additional magic that is happening inside of the Unity editor. Because the Unity editor is correctly assuming that by moving the pivot, we don't want to move the element, it's compensating for that by changing the corresponding X and Y. Watch what happens as the pivot moves into the anchor point. The X and Y approach 0, as you can see right there. As I move away, it goes positive, and as I move behind, it goes negative. So again, the pivot is really what determines the position of an element. For example, let's go ahead and set the position X to 0 and the position Y to 0. In this case, we have a pivot that's exactly in the center of the game object, 0.5, 0.5. Now let's change the pivot to 0.5. You'll notice immediately that our position was modified for us by the Unity editor itself. So let's go ahead and reset our position X back to 0 and see what happens. As you see, it's now aligned to its left-hand side. And as I modify just the position X, you'll notice it approaches 0 as we get closer to the anchor point. If instead the pivot was on the right-hand side, which I can accomplish by going to the pivot parameter and setting the X to 1, you'll notice that as we approach 0, the element is positioned on the left-hand side. This is very, very important. This concept of how position is calculated based on the location of the pivot relative to the location of the anchors. The reason why this is important is there's going to be a lot of scenarios where we need to determine the X and Y value of a particular element for animation purposes, for gameplay purposes, for drag and drop purposes, and so on and so on. Understanding how these positions are calculated is incredibly important. Okay, so again, that's really, yeah. We have our anchors and we have our pivots, and those change depending on what's going on. I want to point out a couple more things. First of all, scaling is different from sizing. I didn't want to bring this up until we saw in this video an example of both scaling and sizing. But let me go ahead and show you guys what exactly goes on when we do that. So I'm going to go to Panel, and I'm going to go to UI, and I'm going to select Text. And I'm going to go ahead and have this text be really big, so I'm going to set the font size to 20. That's not very big. Let's do 28. Of course, it won't fit in its thing. There we go. Then I'm going to set the text to stretch on the size of the parent and be centered. Okay, so on this panel is now the parent of this text. Watch what happens as I resize the panel. You'll notice, well, unfortunately, I don't have the size of the text set up appropriately yet. Then we're going to center it in the middle. Again, what I'm doing over here in the text component is irrelevant. We'll talk about that in a later video. But the point is you'll notice that the text rectangle is actually stretching as I change the size of the panel, but the text itself is not changing. However, if I were to come in here in the scale, in fact, if I were to open up the scale tool, notice how as I scale it up and down, even backwards, the text changes with it. So it's really important to understand the difference between scaling and sizing. Sizing determines the pixel value of something, and it's very, very important to create consistent user interfaces that don't distort text or images. Scaling, however, is a way that we can create some really cool spiffy effects by animating the scale of an element. Anyway, I just really wanted to point that out, just for everyone who may not have noticed the difference between our scale and our size. Okay, there's another thing I want to talk about here. I'll just go ahead and leave this panel where it is, because we'll be able to talk about this tool with the panel that we have set up. And that is this button right here. This button right here allows us to very conveniently set the anchor and the pivot and even the location of a UI element relative to its parent. For example, I can now have it anchored to the left. Notice that by clicking this left preset, we got a 1-point anchor, and it moved over to the center left of the screen. Center moves to center, right moves to right. You'll notice by doing a stretch, we get a 2-point anchor. Then we have this other grid. We have top, middle, and bottom. You'll notice that this gives us a 2-point on the top, middle, or bottom of the parent. You'll notice that we also have a vertical stretch. And this vertical stretch is going to, in this case, give us a full universal stretch. Then we have combinations. For example, we can dock to the top left, middle top, top right, middle, bottom, bottom left, and so on and so on. So this cool little grid allows us to really go in and quickly change our anchors to a very common preset. We also have the corresponding stretches, stretching horizontal or stretching vertically left, stretching vertically center, and stretching vertically right. Finally, we have our horizontal stretches, and then we have our uniform stretch. What's also cool about this is we can also use this tool to set our pivots and our positions. If I hold down Shift, not only will I set the anchor to somewhere, I'll also set the pivot to that same place. So as you notice, the pivot is moving around as I change my anchor position. Finally, we can also hold down Alt, which will change the position of an element. So by holding down Alt and Shift, we can very, very quickly dock a panel to where we want it to go. Want to dock it to the bottom, want to dock it to the top, want to fill it, want to dock it to the bottom right, the top left, the top center, and so on, just by holding down Shift and Alt. Alrighty, so I'm going to go ahead and reset this in the center. And I'm going to briefly talk about one more thing before we recap and end this video. And that is going to be the role of empty game objects. Now, as I'm sure you guys are aware of the technique or have used this technique of creating empty game objects to create a hierarchy of game objects that you can scale uniformly or move around all at once, and so on. Like, let's say you, for example, have a couple of models that you want to move at the same time or rotate at the same time, you would child them to an empty game object, and that empty game object would allow you to uniformly rotate or scale those items. Well, a similar technique can be employed here, and it follows through from the fact that all game objects underneath a canvas will have a rect transform. So what I can do is I can come up here to the canvas, and I can right-click and say Create Empty, creating an empty rect transform. Now this rect transform behaves exactly like all the other rect transforms that we have inside of our scene. You'll notice that there is no visual aspect to our rect transform because we haven't added a text or image component to it. But what makes it really handy is I can actually child real UI widgets to that empty game object and take advantage of all the properties of nesting rect transforms. For example, if I were to take this panel over here on the left-hand side and drag it underneath our game object, it's now parented, or the game object's now parented to our panel. And if I were to give it a uniform fill stretch, you'll notice that it's now taking in this entire space of that empty game object. You can do really cool things with it. For example, I can make this panel take up only half of this game object right here. Then I could come into this game object and add another child to it, such as a button. And then I'm going to have the button dock on the right-hand side. I'm going to do that, and then I'm going to do a 4-point anchor and move it to about 50%. Now, as I move this empty game object, you'll notice that our button and our panel are moved proportionally, all by taking advantage of an additional rect transform in the hierarchy. So I hope this points out, or shows you guys, that rect transforms are incredibly powerful, and introducing empty game objects allows us to create some very complex user interfaces. Alrighty. So basically, this whole video should show you guys that really with a good understanding and a good intuition of the rect transform, you can accomplish very, very complex user interfaces. So I want to go ahead and recap by just bringing up the example that we started with. And hopefully the nuances of this example will make a whole lot more sense. I'm going to right-click on the canvas, select UI, and create a panel. Then I'm going to move it to have 10 units of padding, or how about 20 units of padding around its parent. Again, the reason this works is because I'm in a 4-point anchor, and the anchor is stretched on the entirety of the parent. These values that I just set, left, top, right, and bottom, simply dictate the distance between the edge of the rect and the edge of its anchors. Remember, if I move the anchor points, the paddings will compensate for the change in anchor position. Then I'm going to come up here to the panel, right-click, select UI, and create a button. And this button, you can see, is I'm moving it relative to the center of its parent. More appropriately, or more specifically, I am moving its relative to the position of the pivot to the anchor position. Meaning if I were to change this 1-point anchor position, you'll notice that we're moving the pivot relative to the anchor position again. So, really, what you need to understand is the relationship between anchor points and padding and positions and pivots. And those are really the things that make up this whole system. So again, it's very complicated, or it's not very complicated, but it's a lot to take in. And you might get frustrated with complex user interfaces when you deal with things like trying to translate and move different UI elements from one position to another. And to do this within scripting is a little bit more complicated. There are tools available for you inside of the API that allow you to make these translations, but ultimately it boils down to having an understanding or a solid grasp of anchors and pivots. But I think that just about wraps this video up. So we'll see you guys in the next one.